So this is question 11. So once this is solved this equation, but notice how again, the variable y is in the denominator. So one of the things we have to pay attention to is the denominator cannot equal zero. So what we have to look at to start with is what would make y plus 4 turn into zero? We would see, well, y equals -4. That would make a denominator zero, so we have to exclude that. Y minus 3, what makes it zero? Well, that would be y equals 3, so we have to exclude that. Y plus 6 equals 0. So what makes that turn into 0 would be y equals -6. So notice how we have actually three excluded values, -4, 3, and -6. Now, to solve this problem, remember we want to multiply by the least common denominator to eliminate fractions. Notice that the least common denominator is just going to be, we're going to need a y plus 4 to get rid of it. We're going to need a y minus 3 to get rid of it. And we're going to need a y plus 6 to get rid of it. So if I put all three of those together, that's going to actually be my least common denominator. So let's see if we can actually put this all together. So this is where it gets tricky. There's some math here to do. So what I'm going to do is multiply each side of this equation by this big old thing. So I'm going to have a y plus 4 times a y minus 3 times a y plus 6. And I'm going to use brackets here. So I'm going to multiply all this by this on this side. So it's going to be a 5 and a y over 4. And then plus then this 2 over this y minus 3. So I got to multiply this whole side by these three factors. And then on the other side, I have this 7 over this y plus 6. And I have to multiply this all by y plus 4, y minus 3, y plus 6. So let me make myself some room here. So what has to happen is the reason we are multiplying both sides by this y plus 4, y minus 3, y plus 6 is to cancel out the denominators. So notice that the y plus 4 is going to cancel on the first term, which means the y minus 3 and the y plus 6 is going to be multiplied to the 5. So what I have to begin with then is I have to have this 5 times y minus 3 times this y plus 6, because the y plus 4 got canceled out. Then I have this plus sign. Notice that when I multiply all three of these to the next term, notice the y minus 3 is going to cancel out. So that means we're going to still have to have this y plus 4 and y plus 6 go through, and there's still this 2 here. So I'm going to put the 2 out in front. But since the y minus 3 is canceled out, I'm going to still have the y plus 4 and the y plus 6 go through. So I got to multiply this to both pieces. When I multiply to the first term, the y plus 4 cancels out, which leaves me the y minus 3 and y plus 6 and the 5. So I put those down. And then when all this goes to the second term, the y minus 3 cancels out. So the 2 is still there, and the y plus 4 and the y plus 6. So then I have an equal sign. On the right-hand side, notice that the y plus 6 will cancel out. So those are canceled out, if you will. And I'm going to cancel them here. It doesn't make that big of a deal. But I still have this 7 and this y plus 4 and this y minus 3. So I got a lot of math still to do. So to solve for y, we have to actually multiply the binomial times the binomial together to start with. So I'm going to leave this 5 out here in a parentheses. I'm going to have y times y is y squared. And then on the outer, see if I can make this kind of come out here. So the outer is going to give me 6y. The inner is going to give me a -3y. So 6y and -3y is going to be a plus 3y. That comes in. And then the last terms would be the -3 and the 6 would be a -18. So I'm going to hold off on multiplying the rest of that. I'm going to go ahead and multiply this binomial times this binomial. So I'm going to have plus 2. And then I'm going to have y times y, which is y squared. But then I'm going to multiply the outer and inner, and I'm just going to kind of do it here. So y times 6 is 6y. 4 times y is 4y. So 6y and 4y actually gives me a 10y. And then 4 times 6 is going to give me then this 24. So then I have the 7, and then I'm going to multiply these two binomials together. Y times y is going to be y squared. So the outer is a -3y. The inner is a 4y. So -3y and a 4y is going to give me just a positive y. And then 4 times -3 would be the -12. So then we have to multiply the 5 through. So 5y squared plus 15y, 18 times 5. I didn't bring my calculator with me. 18 times 5, 40, looks like 90. So that's going to be a -90. And then we're going to multiply this 2 through. 2 times y squared would be 2y squared. 2 times 10y is 20y. And 2 times 24 would be 48. And then over here, we're going to have 7y squared plus 7y. But we still got to multiply 7 times -12. I think that's -84. So we still got a lot of math. So notice how on the left-hand side, we can kind of combine like terms. So 5y squared and 2y squared becomes 7y squared. 15y and 20y becomes then 35y. And -90 and a 48. So those are different signs, so I have to subtract. 90 minus 48. So 10 minus 2, 10 minus 8 is 2, 8 minus 4 is, so 42. That does give me 90. But since the bigger number was negative, it's going to be a -42. Over here, we have 7y squared plus 7y minus 84. Looks like I still need some room. So notice how we have a 7y squared here and a 7y squared on their side. So I can actually bring those together by subtracting a 7y squared here and subtracting a 7y squared here. And it looks like those are just going to zero out. That's going to leave me 35y. Oops. Some crazy looking mark. So 35y minus 42. These zero out, so I'm left with a 7y minus an 84. So from here, to solve a linear equation, we have to get the y on the same side of the equation. So I'm going to pick on the 7y. So I'm going to subtract a 7y here, as long as I subtract a 7y over there. So if I simplify that, 35 minus 7, looks like it's 28y. So 28 plus 7 is 35, yeah. So minus 42, the 7y is canceled. So all left over here is a -84. So now to start solving this, we have to get rid of the 42. So if I add a 42 here, that will zero out. Add a 42 over there, that zeroes out. So now I have this 28y. And what's 84 and this -84 and 42? That's 84 minus 42 since they're different signs. Looks like it's 42. So, but since the bigger number is negative, that's going to be then a -42. So let me just keep on going here. So now we're almost home free. So we have to divide both sides by a 28. And we end up with then y equals negative 42 over 28. But that looks like that's reducible. So I can see a 2 in both of those. So if I take a 2 out, that's going to be a negative 21, and that's going to be a 14. It looks like there's a 7 in common there. So if I take a 7 out, that turns into a negative 3, and that's going to turn into a 2. So it looks like our solution becomes then negative 3 halves. So there is a solution, and it is going to be negative 3 over 2. So that's our solution set notation. So if we have a solution set notation, only the value of x goes inside the set notation, so negative 3 halves. So that was a lot of math to try to keep up with. So you notice that sometimes the more you can do mentally, the easier it is to write on paper. It's hard to show every little step, but uh, so feel free to watch this video again to get a better understanding of the question. Take care.